Hello there, welcoming you all in the physics arena by Nitish sir. Students, today we are going to study about more topics of the chapter work, energy and power. So students, in the last lectures we have discussed about the kinetic energy, various forms of the kinetic energy and how we can calculate the kinetic energy possessed by a body, its mathematical expression, and already we have learned how we can calculate the change in kinetic energy which may produce the amount of work done by a body as work energy theorem. So students, with the help of this video lecture, today we are going to state about the second form of the energy which is termed as a potential energy. So what do you mean by potential energy? If someone speaks about potential energy, what first comes into your mind? So the potential energy of a body can be defined as the amount of energy possessed by a body due to its position or state of rest. Okay student, or change in the strain. So we can define here the potential energy of a body can be defined as, so here I am writing, it is means potential energy of a body is defined as the amount of energy amount of energy possessed by a body, the amount of energy possessed by a body due to its position. Okay students, what I have written here, potential energy of a body is defined as the amount of energy possessed by a body due to its position or state of strain What do you mean by strain? Here I have used a new term which is termed as a strain. What do you mean by strain? Strain means that change in its position. Strain means that change in position, students. So with the change in position, how we can calculate the amount of energy possessed by a body is said to be the potential energy of a body. Students, as we are knowing that gravitational potential energy is also a type of potential energy. So with the help of an example, we will discuss about the gravitational potential energy. Students, as we are knowing that, let us suppose that if we are willing to define gravitational potential energy, so how we will define the gravitational potential energy? So in order to discuss about the gravitational potential energy, first we will consider a body of mass small m. Let us suppose that this is a block or this is a body whose mass is small m. This is a body whose mass is small m and which is kept onto the surface of earth. Okay students, so let us suppose that here the height of the surface is 0 and the object of mass m is kept at a height 0 at rest. Now we are willing to move this object at a height h from the earth's surface. So the height of this rack is h from the earth's surface. Okay students, and as we are knowing that the gravitation, what do you mean by the gravitation? Gravitation means that a force of attraction imposed by the earth to pull each and every object toward its center. So we are going to do, what we are going to do, we are going to keep this object from the earth's surface to the height h. We are willing to place this object which is given by the red pen as a here. So in order to calculate how much amount of work has been done to change the position of the object, so at that height h, what will be the amount of energy possessed by a body can be calculated as, so here what I am going to write, let us suppose that a body of mass small m initially at rest. It means that its height is 0. It is at the surface of earth. Now what we are willing to do, now this object, now this body or object is going to be raised. Now this object is raised by a height h from the small h from the earth's surface, So here in this condition we have to do a work done against the gravity, because the gravitational pulls in the downward direction and we are moving the object in the upward direction. Therefore work done by the object against gravitational pull, that the work done in this condition can be calculated as with the same formulation as force into displacement. Students, that amount of the work done will be considered as the gravitational potential energy, and potential energy is given by U. So in this condition, as we are knowing that the force is equals to mass into acceleration, and here the acceleration will be acceleration due to gravity, so we can write that m into g. Product of mass with the acceleration due to gravity is said to be the weight of the object, and h, and here the displacement is as height h. So the product of mass, gravity and height will give rise the gravitational potential energy when a body is kept at a height h from the earth's surface. So in this manner we can calculate the gravitational potential energy stored by a body h. Okay students, now we are moving towards the amount of potential energy of an ideal spring. So how we can consider and how we can calculate the amount of potential energy stored by a spring. So students, now we are going to state about the new topic, that is the potential energy of an ideal spring. So student, as we are knowing that a spring is a spring can be made with the help of a metallic material. So here you can see that we have chosen a block which is tied with the spring whose one end is fixed. Okay, here one end is fixed. So you can see there, when the no force is applied to the block, then the displacement is 0. Here you can see that no force is applied to the object and the object in a state of rest. But as we are applying a strain means that earlier I have given you the idea that strain is nothing but that is a change in position. Now with the help of with the application of a force, we have stretched this spring and now the displacement occurred is x. Okay students, as we remove this force, then again this spring, once spring got elongated, now when the removal of the force happens, this spring will try to move its original condition. Once the displacement occurred is in the positive direction, so it will be positive, and once the spring will move in the backward direction, so the displacement will be negative. So in this condition, with the help of these three diagrams, what we can conclude that this force, what we have applied a deforming force. What do you mean by the deforming force? Students, deforming force means that there are the two factors, deforming force and the next one is a restoring force. So what do you mean by the deforming force and what do you mean by the restoring force? Deforming force is a type of force which may occur a deformation, means change in position takes place, whereas the restoring force will be a type of force will try to regain the original condition of the body. We have applied here a stretching force to change the spring or the position of this body who is having the mass m, whereas when we have removed this deforming force, the object will try to regain its original condition, but bit slightly it will move like from its mean position. So once the spring got elongated and once the spring got stretched. So in this condition we can conclude that this restoring force, which will try to regain the original state of the spring, will be directly proportional to the change in the displacement occurred by the spring and but toward the center, or we can say that toward the equilibrium position. Deforming force is directly proportional to the negative direction of the displacement. From this we can also conclude that if we remove this proportionality constant, we will introduce a constant term as a k. So we can write that F is equals to minus kx, where k is said to be the spring constant, where k is known as spring constant. So if we are knowing that the value of the, what we can conclude from here, we can conclude that, sir, if we are willing to calculate the value of spring constant of a spring, then we should know about the deforming force, restoring force applied by the body to regain its original condition, and also the displacement occurred by the body with the negative sign. What this negative sign indicate? Negative sign indicate that the always this force will be up. You can see here the displacement in the forward direction and the restoring force in the opposite direction. So the direction of force and displacement both are different. That's why I have written here that the deforming force, the restoring force is directly proportional to the displacement occurred in the body with the negative direction. So in this manner we can calculate the amount of energy consist by a body. Students, here we have calculated the force of a body. If we have calculated here the force of the body, then with the help of the displacement we can also go with the calculation of potential energy possessed by the body. Now we are going to proceed how to calculate the potential energy of a spring.